evening, good afternoon, wherever you are. Welcome to the 24-hour PASS Summit preview. So we're going to have a session, multiple sessions actually, going up to the PASS Summit, which is in October. We are excited you could join us today for Brent Ozor and Eric Darling's session, Last Sessions Performance Tuning Techniques. This 24-hour PASS consists of 24 live webinars delivered by expert speakers from PASS community. The sessions will be recorded and posted online after the event. To access any on-demand sessions, please visit 24hourpass.com. My name is Damu Venkatesan, and I'm the moderator today for this session. And I also run a couple of virtual chapters in the PASS, and also I'm part of the local community here in Atlanta. I have a few introductory slides before I hand over the reins to Brent and Eric. Next slide, please. If you require any technical assistance before, please type your question into the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you can ask questions throughout the presentation. Feel free to enter your questions at any time, and once we get the questions Q&A portion of the session, I will read your question aloud to the speaker. You are able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. For sure. It will appear in your web browser. Next slide. I would like to take a moment to thank our presenting sponsors today for this 24-hour PASS, Quest, Melissa, and Nutanix. The staging of 24-hour PASS would not be possible without their generous support, and they are the reason this event is available free of charge. Next slide. Make sure you explore everything else PASS has to offer for data professionals. You can also join local user groups around the world, special interest groups, virtual chapters, find free online resources through our Learning Center, and read up on the latest community news in the Community Connector newsletter. Next slide, please. Next, I would like to bring your attention to the upcoming PASS Summit, taking place in Seattle, Washington from October 31st to November 3rd. PASS Summit 2017 features over 200 sessions with world-class data experts. It's a perfect place to connect, share, and learn from industry experts around the world. To find more information, visit passsummit.com. Next slide. And without further ado, here is Brent and Eric with Last Sessions Performance Tuning Techniques. Eric.
Hi.
Brent, please go ahead.
Ta-da. Hi, I'm Eric, and I'm only here because my dad made me be here. Go ahead, Dad.
I'm Brent Ozar. I'm Eric's dad, or I certainly look old enough to be it. And I'm a Microsoft Certified Master, which just means I talk a lot about databases. I suck horribly at fashion, like horrifically bad at fashion. I was really bummed out in my high school yearbook when I was voted most likely to succeed because what I really wanted was best dressed. And I look back at the pictures now and I'm like, what was I thinking? I mean, I made so many bad decisions. We're going to be talking a lot about bad decisions today, but in SQL Server, not in terms of fashions, although you'll get to see some awesome pictures of us from our childhood fashions. If you want to follow along, the link to all of the demo scripts is down at the bottom of the screen down there, brentozar.com/go/fashion. Everything that we're going to talk about here, you can follow along if you have the Stack Overflow demo database at home. Some of them don't even need demo databases. We're just going to do like my page splits demo that we'll talk about first. You can use in any plain old blank database. So make sure I can click onto the next slide here. It does, it works, oh my God. So today's topic is unfashionable performance skills. There's a great presenter out there, Buck Woody from Microsoft, who likes to say, do you have 10 years of experience, or do you have the same year of experience that you've done 10 times in a row? A lot of us maybe call ourselves senior database administrators or senior database developers, when in reality, we're still stuck in our 1990 skills or early 2000 skills, doing the same things that we've been doing all along. I'm probably like you, well, not in my sense of fashion and gold chains by the inch, but more in my sense of having to learn this thing myself and kind of go hit blogs and Google. And sometimes because you don't get formal training, you never really get a good foundation of here's what's current today for performance tuning. And you're still relying on blog posts from 10 years ago, 15 years ago, that haven't been updated, and there's much better tuning techniques.
Not even using SP-Who 3.
Not Oris. Oh my God. Activity monitor. You know, how many times have we been on calls with people and they've said, you know, what do you use to performance tune? Activity monitor. Oh man, come on, it sucks. So today we're going to talk a little bit about things that you may have seen along the way that are kind of outmoded and maybe you need to grow beyond. At the Full Pass Summit in October in Seattle, Eric and I are doing an all-day pre-con where we're talking about 2016 and 2017 performance tuning techniques, things that are just way better and easier than the crap that you have built inside the databases today. So I'll kick off with the first one and then I'll switch over to Eric after my demo. So the first thing that I'm going to talk about is tracking page splits to reduce fragmentation. Man, when I was young and I really needed the money, I always read all these books and they said things like, well, fragmentation is really bad. And I'm even embarrassed to admit that at one point in time, I did a webcast said that fragmentation is the silent performance killer. And if I could take back one thing in my career, that would probably be it. Thankfully, Eric didn't pay any attention to that on his way through the database world.
I'm just glad you didn't say hiring me, because that would have that was embarrassing in front of all these people.
That was number two. Man, when I found out he actually dresses like this. We always thought the fragmentation was a really big deal. Oh, if the pages aren't exactly in order, then performance is going to be horrifically bad, because all your pages need to be in order, right, for sequential reads. Not realizing that in today's performance tuning, a lot of your data lives in RAM. Quick question, what's the RAM? What's that stand for? RAM, it's an acronym. What's it mean? Random access memory. It's not sequential access memory. You don't need all your pages in a row. But back then, Grandpa Brent only had, say, 4 gigs or 8 gigs of RAM in his SQL server, had the 32-bit SQL server address windowing extensions. So I tracked really carefully, trying to figure out exactly when fragmentation was happening. And there was a perfmon counter that we used called page splits per second. It tracked the number of times that one 8K page was full, and we had to tear it in half to put some data on one 8K page and some data on another. Well, I kept seeing page splits out the wazoo, so I thought, oh my God, I must be having a huge problem in my database. I'm going to set fill factor or go defragment like crazy in order to fix this problem. Well, it turns out that I was way off, and I want to show you how far off I was in terms of a demo. Man, I can't believe the number of bad fashion pictures that I have from my childhood. I loved my K-Swiss sneakers, my BKs, and I would wear sneakers that I think weighed 20 pounds when I was wearing them with the tiniest shorts. I look back now, gold by the inch, big fan of that back then. So we'll go take a look now and see. Now I'm going to run our first demo here. I'm going to pop over this.
About them all is just how carefully posed they are. Like, thoughtfully, just like an album cover.
My mom was so into photography, and she'd be like, "Okay, now I'm going to get you behind the plants and get a little soft focus here." And I'm like, "Mom, could you smear Vaseline on the camera or something, maybe make me look a little better?" So what I'm going to do is I'm going to go create a table. And it doesn't really matter where I put this table. I'm, of course, a huge fan of 90s one-hit wonders, so D-Light's Groove is in the Heart. It should infect your ears this morning. I'm going to create a table. It's got no rows in it. It's just got an identity field. Clustered index starts at 1 and goes up to a bajillion, however many rows I put in there. No pages in there so far. And then I'm going to check this perfmon counter for page splits. You can access a lot of SQL Server's performance counters from inside the DMVs. You can't get the Windows level perfmon counters. That's what I really wish you could get, but well, that's something for another day. Now this perfmon counter is cumulative. I know it says page splits per second. You would think that means page splits per second, but it's actually cumulative since the thing restarted. So I'm going to execute it again a few times just so you get a feel for there's no other activity happening on my SQL Server, and if we're Eric's SQL Server, really. So if you look
Who
at here,
knows, there might be stuff going on in there.
I
I lost control of it months ago. It's become its own thing.
Ever since the ransomware hit and all the ransomware guys were like, this is the perfect server to store all our Bitcoin transactions.
See, now, Brent, I think that might just say page splits divided by seconds. I don't know. Maybe there was just some lost in translation there.
Or maybe SEC stands for secure. These are secure page splits.
They might be.
So it ends in 04. So there's been however many 04 page splits. Now I'm going to go through and add just one row into our brand new empty table. And after adding just one row, I go in and I run my page splits counter again. We had 04 before, and now we have more. We just had a page split.
Oh dear.
All I did was add a new row to a table. See, here's the crappy part about page splits. The page split counter does not mean what you think it means. The page splits counter is the Milli Vanilli of perfmon counters. Girl, you know it's false. It turns out that it also includes every time you add a brand new empty page to a table, page splits is included. So I know so many people who are playing around with fill factor and trying to defragment in order to reduce page splits, not knowing that anytime you just add more data to a table, you can still end up with page splits just by adding on additional records or additional pages into an existing table. Man, first absolute heartbreaking piece. So Eric, now I'll hand it over to you for our next last season's thing.
Cool. So I'm going to talk to you about table variables because I hear a lot in consulting that, you know, table variables are just as good as temp tables and everything's fine and everything's equal. But some people just don't know that there might be differences. Some people just create a temp table one day and a table variable the next day. That doesn't really matter what the use is or what they're doing with it. You know, so one day it might be a table variable just because there is no rhyme or reason to it. It's just one big coin toss. And one day it just might be laziness because I know what it's like when you have to create a temp table with that many columns, because I've done it in stored procedures where like you have these gigantic temp tables. You're like, I don't want to write that create table out. I don't want to sit there and give every one of those columns a data type and figure out if it's null or it's not null or what I'm doing with it. I'm going to let SQL Server decide. I'm going to use the magic of select into and just use a temp table because you can't do that with a table variable. And I'm just going to select all these columns into it because I'm lazy. And I'm fine with being lazy. So you may have heard some things around the blog, especially specifically if you read my blog, you poor souls, poor souls. That there are some downsides, there's some bad things about table variables. Like modifications are always for serial. You only get a one row estimate unless you use a recompile hint, which just defeats the purpose of a table variable anyway. And finally, you may be finally ready to let go of table variables being in memory, because if you have a 10 gig table and 8 gigs of RAM, and I know all of you have that crappy VM with 8 gigs of RAM because you have that awful VM admin, Windows and SQL do not gang up together to say, oh, we're going to make this 10 gig table 8 gigs so this table variable fits in RAM because it's so special to us. It is the most special, precious table variable that we have. So I'm going to pop over to Management Studio and I'm going to go through some of the crappy things about temp tables and table variables, and I forgot to scroll back up to the top. So I'm just going to make sure I'm using the right database since Brent used master and then put the table in TempDB like we talked about. Way to go, Brent. Way to fly off script. So I'm using my column stored version of the Stack Overflow database because it's really good for aggregations like this. it just takes so much less longer. We're going to be focusing on things with a vote type of 16. I don't know what a vote type of 16 means. I just know it's kind of in the middle of the pack as far as how many rows it has in the votes table. So I'm going to make sure that I have query plans turned on because I don't want Brent to laugh at me. And the first thing I want to show you is that there's no such thing as a parallel modification to a temp table. We're going to use an insert here just because it's easy to demo. So I'm going to stick some data into my table variable, and we're going to see that we have a serial plan. I don't have my little parallel badges or anything. And now I'm going to go and I'm going to show you something cool from the future. And it's not that, and it's not what you think. I have Brent's head in the future too. Sorry, Brent, you died.
My brain is in there as well. Yes.
Yeah. Well, actually, I emptied it out, but it's no big deal. I ate your
really
brain
small.
in the future. So in the future, in 2016, we have this cool new parallel forcing hint. We don't have to use a goofy trace flag anymore. And I run my query again. I run my insert again. With this parallel forcing hint, I still have a serial plan. And the reason for that is buried in the XML. It's right up here. It's hiding there in plain sight. And this has been there since SQL Server 2012. You get a degree of parallelism equal to 0 in a non-parallel plan reason that says I could not generate a valid parallel plan. And that's a product limitation on table variables. There's no such thing as a parallel modification to them. The other thing is that they're not guaranteed to be in memory. So I'm going to use a cool query profiling tool called Set Statistics. I'm going to turn time, which measures CPU, and IO, which measures disk poundings on. And so I'm going to show you what happens again when we reference a table variable. So I'm going to declare my table variable. I'm going to insert that same amount of data into it. I'm going to select a count. And you know I'm not lying because that count is still the right amount of rows. If I go over into the messages tab where all the information from set statistics, time, and IO on pops out to, you'll see right down here, I have a temporary object. See that pound sign object? That is how SQL Server creates our table variable behind the scenes. It is a temporary object, and that stands just as much chance of spilling to disk as any other temporary object. Isn't that stunning?
And isn't it, I heard, I don't know if this is true, but they call them pound, objects because they absolutely pound TempDB. Is that,
They
I don't
sure
know if
do.
that's true. Yeah.
Give it a good pounding.
Mm-hmm.
Back alley pounding. So let's talk about crappy estimates, because there are crappy estimates in these table variables. We're going to hit F5. We're going to go to the execution plan, and we're going to look at our select count query. And we see this table scan here where we have one execution, and SQL Server is all up and down there, estimating one row. We're only going to have one row. There's only ever going to be one row. But then a little bit higher up in the tooltip, it tells you that the actual number of rows read and the actual number of rows is our 1.8 million number. Isn't that confounding? That's no good. And where that can come back to bite you is when you go and you need to join a table variable off to a real table or even to another table variable or even to a temp table, because you're going to get that crappy one row estimate and you're going to get a not quite great plan out of that. You're going to get something like this where SQL is estimating one row and I get this nested loops join for a really big join. Like a couple million rows is not great for that. And part of the reason that this bothers me is that one row estimate gives you a very, very low query cost. When you estimate one row, your query cost is going to be teeny tiny because SQL is only going to think one row is coming out of this because one row comes out of this, and now your query cost is nothing when it's actually kind of an expensive query. Now, if I force that parallel using our futuristic plan hint and not just Brent's skull,
Dun, dun, dun.
and I go back into my query plan, I get a parallel plan. So you can get a parallel plan selecting from a table variable, but you don't often get it because that one row estimate puts your query cost so low that you don't break the threshold to go parallel. So no matter how much work you're actually doing, you get all messed up. Recompile does not help. In fact, we'll see that recompile hurts a little bit, and we'll look at something that Brent said, where they're called the pound sign tables because they pound TempDB, right? It's a pound, and this is going to finish in 12 seconds, so just count to 2. Well, I'm from the future. I knew that was going to happen. If I go into my execution plan now, I have this hash match, which SQL said, oh, we have a bunch of rows coming out of here. I'm going to make a hash and do all this stuff. It spills to TempDB now. So now I'm not only do I have this awful plan, but I'm spilling to disk. So I'm pounding TempDB, and that's god awful too. If I do that same thing in parallel, it finishes faster. But guess what? SQL still hates us so much for using a table variable. Now we spill to disk twice. We do it once here, and one's here. So we're just getting our butts handed to us. This is no fun. So what I'm going to do now is show you some temp table superiority. So I'm going to create a temp table, and I'm going to do the exact same thing, joining our post table, and I'm going to run that, and that finishes, you'll notice, a little bit quicker. But more importantly, we get a pretty reasonable execution plan. We have no spills to disk. We're using a hash join for a 2 million row 1.9 million row joins. That just makes a lot more sense to me. It's a lot more sensible. Now, you can index these things, and you can try to stick indexes on them to help, but guess what? Table variables don't give a gosh darn about your indexes, not one bit. We still get the same plan, it's still crappy. If we do the same thing with a temp table, it still rules. It's still way better. We still get our hash join, everything makes way more sense. And due to the magic of Column Store, we have a parallel insert.
Dun, dun, dun.
Thanks, Column Store. I'm sorry I ever doubted you. Anyway, that's a little bit of temp tables versus table variables. I'm going to hand things back over to Brent, who's been patiently waiting in his finest Andre Agassi jacket.
Right, pretty spiffy. And the thing I love about the temp tables versus table variables thing is people think that they're just keeping everything in RAM, when in reality their horrible query plans end up nailing tempdb over and over again. It's so awful. All right, so next up, let's see what we got here. Guys, we should show that slide just because it's so unbelievably epic. This is one of my favorite slides that I've ever seen come out. Eric designed. This is Eric as a child when he used to play, but you say he's just an estimated plan.
I forgot that slide was in there.
That's so wonderful. All right, so next up is separating data and log files for better performance. If you go out and you read a lot of older blogs, yeah, you would read all these advice, and books especially. Back in the old days, they would tell us things like, well, look, magnetic hard drives, those spinning rusty frisbees, they were really fast if the moving head was kept in the same place, which meant they could go sequential. But if they jumped around from place to place, jump around, they were really slow at random activity. Then the other thing that they told us back in the books was, look, SQL Server's log file access is sequential. We start at the beginning of the log file and we write continuously to the end. If we could isolate sequential activity onto its own drives, it would go way faster. Now that's kind of sort of true. Even today's solid state drives are still faster at long sustained sequential operations than they are at random. Oh, I should have learned to do the robot too before I got on here. It's too late in my dance career to start now. There's no talent coming at this day and age.
It's all right, we'll hire some robots.
Oh, to background dancers. That's what we needed in the webcast. Background dancers. We'll have to ask Pass if they'll ever let us do this again.
We get a choir too.
Hey man. Now I have Madonna videos dancing in my head. So you see on there is Crystal Disk Mark, which is the kind of industry standard tool for quick, easy disk testing. It's not super deep and accurate. It's just quick, easy disk testing. And the top line is sequential access on my Mac Pro trash can at home versus random access. It's like 10 times faster to do sequential access as opposed to random access, even today on solid state drives. But there's a part of that that's not true. When they told you that log file access is sequential, that was true back on Grandpa's database server when he only had one database. And you would see people running benchmark tests like some of the TPC benchmarks out there. They're in one database. That's not the SQL Server that you have. You have 20, 50, 100. In one recent case on our Office Hours webcast, 6,000 databases on one server. They're not taking turns to write. They're all having a party in the database and everyone's invited. There's log file activity happening all around the place. So instead of doing sequential robots straight through, you're jumping around from one log file to another, writing all over the place. There's hardly any such thing as sequential writes to a log file drive in SQL Server. You end up getting even worse when you start sharing that storage across lots of SQL servers or across other VMs or Hyper-V servers. if they end up sharing drives or you end up doing virtualization or lots of databases, it's just not a magic performance button to separate your data and your log files. This is my sister and I back at very young ages. Man, we used to love each other so much. That was right before she started putting tree sap in my hair. Oh no, I'm not giving her the time of day now.
You know, I was about to make a really awkward, well, what would have been a really uncomfortable joke. I was going to say, your log files don't know that they're sharing a drive, much like Brent's girlfriend didn't know she was sharing him. Then it turned out to be your sister. You should have practiced this a little bit more. Now I see the family resemblance and I feel awful.
My sister and I constantly joke that one of us is probably adopted. We're just not sure which one because we're like not at all alike. My dad is like 5 foot tall. My mom's 6 foot tall, and I'm taller than both of them. I don't understand how this works. So the key takeaway here is that just don't think that by separating your log files, suddenly your SQL Server is going to be magically faster, especially in cases even with dedicated local storage. If you start taking away drives from some part of your SQL Server, like taking away files from the data drives or from the log files, you can actually end up slower instead of faster. So next up is Eric.
Ugh, me again. Back from the future, where thankfully scientists have harnessed global warming to turn the world into a beach called America. So there are some things when I talk to people that I always hear about common table expressions. And they're all very depressing things. Like sometimes I hear that they don't use indexes, which is odd to me because they're querying tables that, well, hopefully they have indexes on them. If they're not using indexes because the tables don't have indexes, that's not the fault of your common table expression. I also hear that much like table variables, they're in memory only. They just hang out in memory because that's where you query them and that's where you left them and that's where they're going to stay. Or sometimes I even hear that SQL persists the results. It takes and it makes an actual table out of your common table expression, which is true in some other database platforms, which will remain unnamed here. But you know, that is true some places. And I also hear that they're better than derived tables, which is silly, because derived tables and CTEs are just the same gosh darn thing. And I also hear the most exhausting thing that I've ever heard about CTEs is I tried them, but they didn't work. I don't know. You said that you were a DBA with 15 years of experience, but when you tell me that you tried CTEs and they didn't work, I start to have my doubts about you. So many people who have these misconceptions call themselves senior, and they're really lousy misconceptions to have, especially when you've been using something for 10 years. You know, I've been drinking beer for 10 years. I know that it's not just magic water. I know, sorry. CTEs have many fine uses. They're great for making query intent more clear if you're using paging queries or if you're getting around wide queries, but where they don't help is, well, all the other stuff that we talked about. So I'm going to flip over to my other demo, and I'm going to make sure that I'm using the right database, Brent, and that I have all my stuff set up. Now, where CTEs don't matter, and how you can kind of prove that they don't persist results anywhere, is if I run these two simple queries back to back. Now, in the top one, I have my where clause inside the CTE, and in my bottom one, I have it just outside the CTE. And when I look at the query plans, they do the exact same thing. There's no difference here. Where CTEs get tricky and where you need to be careful with them is when you start joining CTEs to things. Now, if I join this CTE to itself once in my query plan now, I have I'm using two indexes and I have a nested loops join, which I guess makes sense because I used a CTE, but now I've read two indexes into memory, two different indexes into memory to do one join on a CTE. If I join that CTE back to itself 2 times, all of a sudden my query plan gets a little bit bigger. And now I have 3 index accesses to run this one CTE. So it's not being persisted anywhere. SQL is not creating that result set and saying, oh, we'll just save this for later just in case Eric needs it. And you can prove that a little bit better by using, let's say, 10 joins. So if I join this table back to itself 10 times, at least it should be 10 times, it might be 11 times, and I get that same 22 records back, my execution plan gets awful. It gets awful. So I have 10 index accesses here just to run that query. So every time you reference a CTE in a join, SQL has to re-execute that syntax. It does not persist it anywhere. This isn't true if you nest common table expressions. So this query here just has an additional CTE in it right here. So it's a comma, right? So I just have more freedom. I hope Chase doesn't sue me. So if I run this, I only hit the index once. I'm only referencing that query. So it's cool there. Not so much when you're joining it to itself. Derived tables, they are not better. There's no difference. I have the same query. One is a derived table right here, right? From this stupid select as X. And this one here, where I have my common table expression. And I get the same query plan from both. They don't do anything different. There's no difference there. Where CTEs do shine and where they are cool is if you want to use some very futuristic syntax. If you want to use some windowing functions, and you want to filter on those windowing functions, well, the laws of logical query processing say that this query will fail, and it does horribly, miserably, because this is in the select, and you can't, and the where happens logically way before the select when SQL processes a query. So stuff that you materialize up here isn't available down here. Where you can do that is with a CTE or a derived table, technically, but we're talking about these today. So if you run this query, all of a sudden I can filter on what comes out of my windowing function. So if I do some pre-aggregation up there with my table, with my CTE, I can go and filter on it down here in a query outside. But you have to be very careful where you use top expressions in common table expressions. I have my top 100 on the outside here. If I switch that and put that on the inside, I no longer get my nice 100 rows back. I should get, any guesses? I'm going to say 20 because I've run this before. 20 rows back because SQL aggregates things differently. It does the top 100 inside and it calculates the rank over here. And so it's looking at a completely different result set than it would otherwise. So you have to be very careful where and how you use CTEs. And they do use indexes, as we saw. So Brent, I'm going to pass it back over to you.
Woohoo!
Oh.
As you can see, I during the break, I went over and stood next to a 1990s Geo tracker that was getting pinstriped, and they just sprayed the. I love this color. Nothing is like this color. It's exactly like. Oh, you got your functions one.
Oh man.
Yeah.
Okay, what the hell? We'll finish strong with you then. All right, so the next thing we're going to talk about, well, Brent stands there awkwardly looking like Vanilla Ice.
Just like I did pretty much for all of the 1990s, standing at the side of the dance floor. No women anywhere in sight. Yeah.
Guarding the punch bowl, holding the wall up. All right, so another frequently heard misconception is that functions are optimized just like stored procedures. There have been reams and reads of pages, and I don't know, what do you call a lot of blogs? Is a lot of blogs still a ream, or is that something?
Oh, I mean, it's like a herd maybe, or a gaggle.
Yeah, I don't know. But a whole lot of blog posts have been written about all the wonderful optimizations that you can potentially get when you use stored procedures in your code. I hate functions. It's like I didn't realize how much I could hate functions until I stopped leaving the house and seeing people, and I was like, oh, now I just hate functions instead. So particularly scalar valued functions, and that's me with my He-Man sword coming up to destroy some scalar valued functions. I don't really
have
a
belt there.
That's
impressive.
That is. That was my junior weightlifting belt. Didn't work. So this demo, this isn't really a part of the presentation that's long on words. This is more long on demos because you really do have to look at all the awful things that functions do in order to understand why they need to go away and why you shouldn't be using them. So hopefully this control and tab thing will work for me this time. So I'm going to switch back over into my function side, and I'm going to, well, do I have to? No, because you didn't create any goofy indexes. So good, that's going to fail miserably. All right, perfect. I'm going to set some more stuff, and I'm going to show you something that people frequently have to do in SQL Server. And that frequent thing is taking a list and turning it into a comma-separated list. And the only way to do that prior to SQL Server 2017, where we have the string ag function, is to try to remember all this god-awful for XML path stuff, which unless you're Aaron Bertrand, you can't do. That just doesn't work for you. So this is my query, and if I run this query, it finishes reasonably quickly given all this awful XML stuff that it has to do. But you're like me and you're lazy and you don't want to remember that. You want to turn that into reusable code. So I'm going to create or alter this function because I'm from the future again. So I can use create or alter. And I'm going to call this function fake string ag. And when I use fake string ag and I run this and it goes crazy, what happens is I can now use this function all over the place. I can stick fake string ag on the badges table again, and I can get all this stuff back, and I can even use it in a completely different query that hits the users table. And if this query ever finishes, I can use it over there. I'm going to hit stop. I'm going to hit it on the users table, and see, I can now reuse my code to get this aggregated, this comma separated list of stuff really easily, and that's so nice. It's so nice that I can do that. But there are some problems with that. And we're going to look at those problems by looking at another futuristic component of SQL Server, and that is the query store. The query store holds everything. It remembers everything. It forgets nothing unless you hit the purge button. So it's a lot like me when I hit the Lagavulin button. So what I'm going to do is I'm going to turn off query plans before else this gets real messy. And I'm going to run over here, and I'm going to exec SP Blitz query store with a little bit of information. And I'm going to give it the start date of the recent date time so that you guys only see stuff that's happened recently. And I want you to pay attention to some stuff that comes back. So right now we have the plan ID for our function over here, and we're going to get some more information on that. But I want to take this plan ID and we're going to filter on that right over here. And I'm going to pull this, and that's probably going to be the wrong one, and it's going to look awful. Right. And I should have just left that as it was. So if we look at this for plan 3772, which is our function, we can see over here a little bit further. No, wrong one. Oh, that's right. I was wrong. I was doing this right. I was doing this right the whole time, and I got ahead of myself, and I was stupid. So our query that calls the function only runs the one time. Our function itself, we can filter on our function name. Our function name, our fake string ag function, has run a whopping, astounding whole mess of times. I'm not going to count that in front of you people. That would look bad. So this is what happens. Functions execute once per row. So on top of all the bad things that they do to parallelism, they also have this awful overhead where they function once per row. So I hate functions, and so should you. Now people will do lots of weird things with functions, like they'll put them in a computed column or put them in a check constraint. But now if I create this table called little badges, because if I tried to put this computed column on the entire badges table, we'd be sitting here for a really long time. So if I stick this function in a computed column on our little badges table, and I insert data into it, that goes pretty quick. It does a lot of work to do it, but this part is important. What happens? This part is very important. If I run these two, right? If I run this query and I select data from the table and I select top 10, this doesn't turn execution plans back on.
It's nice and quick.
I even warned myself. It's a good thing I didn't tell myself to do that. I run this query. It doesn't go parallel. We don't expect it to, but we're limited again. We cannot generate a valid parallel plan. Doesn't that suck?
Because you have the computed column in there.
Yeah, just because of the computed column, but it gets worse. Even if you avoid the computed column, even if we leave that computed column off and we look at the execution plan again, we still have that same problem because it's on the table. So every single query, regardless of whether it touches that computed column or not, runs serially, is forced to run serially. So if this were like a big, important, expensive query that you want to go parallel, SQL's like, nah, but sorry, man. You used a function. You can't do that. It also messes stuff up if you do something with check constraints. Now, again, because this is such an awful process, I have to truncate my little table just to add this check constraint, or else Brent would also go as bald as his skull. So I'm going to add this, and I'm going to do a quick insert. And what I did ahead of time was I cheated a little bit, and I ran an extended event session because really it's no fun watching another human being click through extended events menus. I was in front of you, but then I said no, Brent would disapprove. So I already had it set up over here. Now, just to insert 100 rows, I get 200 executions of my function because it has to run once for the computed column and it has to run once for the check constraint. So the overhead of function execution is right back, and it doesn't make a difference at 100 rows. As you get up into larger and larger sets of data, it can really profoundly screw things up. Now, I'm going to get rid of that table because it's an embarrassment, and I'm going to show you a better way to write functions, and that is with an inline table valued function. So rather than returning a single scalar value, this returns a table, right? Isn't that nice? It returns a table because you're using a database where we should be using tables. Let's be honest here. We should all be on that page together. So now if I take that and I run these two things right back to back, they finish very quickly, and I don't have all that overhead because an inline table valued function doesn't get optimized the same way a scalar valued function does, where it just keeps executing. Now I'm going to show you over here where that's true. So if I run this and I look for my fake inline string, we skip the whole process because we can't find that store procedure or function looking in query store. And if we look over here in query store, we see a whole bunch of bad things that I've written to drop indexes and cause spools and be scalar functions and fake string ag and get user crap, I guess. But we don't see fake string ag inline anywhere, and that's because inline table valued expressions are just optimized as part of the query. They don't get logged as being this separate black box of information. Isn't that nice of inline table valued functions? So there's my crap over here. So I'm going to pass this back over to Brent so Brent can talk to you about whatever Brent was talking to you about. And that was a bad click.
Yeah, not to mention that those inline functions, they don't inhibit parallelism the same way that scalars do.
They don't.
Yeah.
You can get a fully nice parallel plan out of that.
So the next thing was believing the missing index hints. Now, I like the missing index hints. I work with just enough other databases, with enough like MySQL and Postgres and Amazon's DynamoDB and stuff like that, where when I look into SQL Server Management Studio, it's an unbelievable gift. I adore it. It's wonderful. Anyone who complains about SSMS should spend an hour or two working with MySQL, or as Eric recently did, SAP HANA. So when you play around with this stuff, you come to realize what an amazing tool SQL Server Management Studio is. But it's just that not every gift in there is a thoughtful gift. Some of the gifts are a little bit less thoughtful than others. Look, you're lucky to get missing index hints. DBAs on other platforms would kill for this, but you just need to put a little bit more thought into this particular gift to see what's going on inside of it. In order to show you what it is, the best way is to just start running a few queries that need missing index recommendations. That was my first cellular phone. Dun, dun, dun.
Wall Street Brent.
Wall Street Brent. His baggy acid wash jeans. So let's go see what we got over here. Let's see here, missing indexes. Now I'm going to pop back over into Stack Overflow because I'm going to be using the Stack Overflow tables for this one because I want something just a little bit big. Just to be safe, I'm going to drop indexes. Eric and I are just like you. We have a stored procedure that drops all of our extra indexes because why wouldn't you have that in production?
I heard it's a good thing to do before you run CheckDB.
Sure, or take backups.
Yeah,
your backups are faster when you don't have to worry about that.
That's so cool.
So what I've got a little bit of a query here. It's only got a few joins in it. It's not a really big, terrible thing. But it's joining a few different tables together. It's joining the users table together, it's joining comments, and it's joining posts. None of these tables have non-clustered indexes. They only have clustered indexes on ID. So I would like to get index recommendations from SQL Server. And you see there's one right at the top of the plan. It says, hey, Brent, your query would be roughly 20% faster if you added this index on comments. And that's probably true. I can right click on that and click missing index details, and it will show me here's the index that it wishes that I create. There's a problem though. If I switch back over to that query, notice that some of these arrows are kind of large. We're doing pretty big clustered index scans on these. I bet there's something hidden inside here. Check this out. Right click on here, and instead of hitting missing index details, go show execution plan XML. Now before we hit it, I want you to look at the missing index and remember that the one SQL Server recommends has about a 20% benefit. Now, when I go into showing the execution plan XML, and I look down in the I know I should have warned you before I show you XML at god awful 30 in the morning.
That's all right. I didn't either.
Like Mullen, there is a missing index here on the comments table that would have made the query 20% faster. But check this out. There can be multiple missing indexes inside the plan. They're just not shown to you in the GUI. Literally, the first query or the first missing index is not the highest benefit, only the first one. So this is really important when you go to do query tuning. Not only, anytime you see a missing index request in SSMS, you've got to drill deeper. You got to go look at the XML. But even looking at the XML isn't enough. Let's take a look at an example of another query. So back over here, I'm going to go down to the next query in the list. And remember, all of these are available in the demo links. If you go over to our blog today, we've already published those, so you can rerun these yourself. I'm going to take another query, and I'm going to get the estimated execution plan for this guy. In here, in the Stack Overflow table, I'm saying, go show me all of the users named Brent Ozar, and then I want you to sort them ordered by age. So first, filter for just Brent Ozar. Second, order by age. Now that missing index request, take a good look at that related to the query. What's on that missing index request? Only display name, and that's it. But notice that your order by is also on age. If you as a human being were going to create this index, you might put it on display name and age, not just one of those fields. Missing index requests are really just the starting point. They are a hint from SQL Server that you need to go looking a little bit deeper in terms of your indexes. They are not the last word. They are just a lucky byproduct that you're lucky to get when SQL Server is going through the process of building an execution plan. I really think of them as a hint, just like we give hints to the Query Optimizer. This is a hint to you to saying, all right, it's time for you to start digging a little deeper and start examining the indexes on this table.
It's a cry for help, really.
It's a cry for help.
You know, it's like taking 5 Advil and saying, I'm going to go to bed forever now. No, you're not. You're just,
yeah. No, take some extra time now.
You're just being a jerk.
Yes. All right. So, do we have enough time for one more?
Yeah, this is quick.
Fire away.
All right. Hosts be damned. So, 2017 and even SQL Server 2016 have been a death knell for many trace flags. It used to be that if you wanted to run SQL Server on what simply we call a big box, you needed about 1 trace flag per core of SQL Server in order to do that. And by big box, I don't mean that 2-core, 8 gig of RAM VM that you have sitting there that you're comparing all this performance stuff to. I mean a big box. If TempDB performance sucked, you needed trace flags 1117 and 1118. If you hit those awful CMEM thread weights, you needed trace flag 8048. And if stats didn't update often enough automatically, you needed 2371. And it didn't end there. The list of trace flags that people use in production just to get these little itty bitty bits of performance or information are absurd. There is just a crazy number of them. These are just ones that I could think of off the top of my head that I'm okay with seeing. These aren't ones that I see and I freak out and hang up the phone on people. 2016 and on, there is just no more trace flag rocket surgery. Or Brent, what's that? What is that noise? What are you doing?
I'm putting on
that looks inappropriate.
Slap bracelets. I mean, it's the same thing that I do with trace flags. I just slap these things on wherever.
You get those from Kissing Boys? I hope.
Hey, well, only the first 2. Yeah.
Why is that one gray? Anyway, for SQL Server 2016 and on, you get all of this cool and all of these cool features turned on by default. Trace flags for TempDB are automatic. So you don't have to turn on 1117 and 1118 to get these performance benefits. And you also get that cool new feature during setup where SQL's like, no, we're going to create we're going to create a data file per core so you don't have awful performance. Auto update stats threshold is just the same as it was when you have 2371 turn on, and you get automatic memory partitioning, so you don't need 8048 anymore. So there's kind of sort of no more CMEM thread. Like, it has to kick in and happen when SQL detects CMEM thread, but it's cool that it does that on its own without you having to restart SQL with the trace flag turned on. That was all.
All right. So folks, I know several of you have asked if we're recording this session. We totally are. We've had Ben at the Boombox on the whole time, so we've been recording all of it. Also, if you got a lot out of this, make sure to go check out the PASS Summit. Go to passsummit.com. Eric and I are doing an all-day pre-con where we talk about not last season's performance tuning techniques, but this season's performance tuning techniques. We're going to talk about stuff that you can use in SQL Server 2017, 2016. Microsoft has been incredibly generous to backport a lot of this, even into service packs in 2014 and 2012. We'll talk about during this session which ones of these work still in 2012 and 2014. If you haven't gone to a performance tuning class in the last year or two, this is your sign that maybe it's time to get your skills with the times. Stop playing around with, for example, looking at missing index requests and hoping that those are going to tell you everything that you need. If you were surprised by things that you saw in here today, that's your big hint that it's time for you to go check out our pre-con at the PASS Summit this year. You can learn more now if you go over to brentozar.com/go/summit, where we have a whole page about that pre-con and help get you started there. So Damu, what questions have we had from the crowd there, our adoring fans?
All right, thanks for the great presentation, man. It was like entertaining and a lot of learning experience there. Cool.
Great, glad you liked it.
Yeah. So questions like M. McDonald asked, would the option recompile help when filling the table variable as opposed to where it is used? Will it cause a statistic update based on the rows filled?
Not one that will be helpful to our query. Table variables do not get statistics generated on them at any point, so it just doesn't matter.
Okay, cool. Someone thanked for you mentioning about the 6,000 plus databases on that, so Jeff Spencer.
Okay. I think our record right now is 12,000 databases per server, and it's just, you want to know about a bad time, that is a seriously bad time.
There's also a record of 15,000 schema in one database, which is
yeah.
Didn't help.
Heinous.
Yeah, another question for Brent is, are you suggesting there is no need to separate log files from data files if there are more than one database?
It's good. I'm glad. So someone was actually watching. Yes, this is one of those concepts where you have to kind of rewind it in your head. You may want to watch the recordings too to really digest everything that was said inside there. There's several different reasons why you might want to separate your data and log files. If you go back through the deck, and the deck is online at our blog now too, we also talk about why there's less of a reason to separate them for reliability purposes as well. These were things that held true back in the really old days when we had one database server and dedicated physical RAID arrays sitting attached to a SQL server. That's just way less important these days in modern servers.
You can tell that's outdated information because it all comes to you from Morse code. When Brent says they tell you, he means they're actually sitting there telling you that in Morse code. So it's,
if you're reading it on a stone tablet, that's your hint. That it's
you don't have, if your RSS feed is a Western Union telegram.
That was from Ihailam Tikeba. That's the name of the person that asked. So next question is, how about the impact of RAID configuration on the performance of log and data files?
Yeah, that can matter. For example, mirrored RAID sets as opposed to RAID 5. The catch that I often run into with people though is they'll start experimenting with things without looking at their server's current bottleneck first. You've only got so many hours in the day. I can tell by looking at your fine antique swatch. You want to focus on the things that really matter on your SQL server. Wait stats, and we're going to show you how to gather that data inside the pre-con. Focus on the bottleneck that your SQL server is having. because you want your users to notice the difference. A server has never given anyone a raise. Raises come from people, and I want you to be able to do things that people are going to notice. That's where focusing on your biggest bottleneck starts out at.
But TempDB on RAID 0 is cool, right?
Fantastic. RAID 0's zero overhead is what that means. It's really fast. You're joking. Those of you who don't know that Eric and I joke a lot.
Hey, next question is for Eric. What will be the replacement to use if you hate functions?
Different kinds of functions.
Okay.
Specifically.
So what I focused on was scalar valued functions and the overhead that exists there. There's another type of function that I didn't spend any time on because we don't have that much time. But there are multi-statement table valued functions which use a table variable, which we did talk about, which are just as awful for many reasons. And if you caught the end of my demo, what I did was rather than use a scalar valued function, I used an inline table valued function, which removes a lot of the performance overhead and penalties from using functions.
Garland SQL Mac on Twitter says, Brent, you need a bigger boombox. Listen, size does not matter. You know, I learned this back in the 90s, even with my small boombox. I can annoy the neighbors enough that I get arrested.
Okay, next question for Eric is, how about table value functions? Our vendor uses them throughout their code, and it seems to be a major source of performance issues.
So there are two kinds of table valued functions in SQL Server. There's the multi-statement table valued function, which uses a table variable in it to produce results. And then there's the inline table valued function. So what you have to do is when you see these functions crop up, watch the syntax of them, because I'm willing to bet that there's like a while loop that does a string splitter into a table variable that calls a trigger that does 15 other things. And those, if it's a multi-statement table valued function, then there can be cause for concern. 2017 does introduce something kind of cool called interleaved execution, which gets you a much better cardinality estimate when you join to a multi-statement table valued function. But you're probably not on 2017 if you're here watching me, are you?
Okay, and so someone asked, where can I get the presentation and also the Stack Sample DB, the Stack Overflow Sample DB?
I don't think we had a link to that.
Yeah, no, it's in the today's blog post. I'll jump over to it now, make sure I get there. It is at the bottom of my bio slide, at the bottom down there. It's brentozar.com/go/fashion, where you can download this entire slide deck, which, yes, Drew asks, where can I get the pictures? They're in that slide deck as well. And the links to download the Stack Overflow sample database. Be aware that it's a 100 gig database. It takes like 12, 14 gigs worth of BitTorrent download. So it's not something that you want to do from work unless it's your last day at work.
Or unless you don't care.
Yeah. Or unless you work for us, yeah.
Next question. What about multiple CTEs in one query? Are they good or not? Because they cause compilation timeouts.
Oh, well, it sounds like you're running into a very specific scenario with the code that you've written inside those CTEs. CTEs in general will not cause that to happen. The code inside them will. So perhaps it's time to invest in some temp tables, sir, or madam.
Yeah.
Or moose.
Okay, so
I don't know.
All right, next question. Is there a time when table variable is useful?
Yeah, totally. So if you're just doing like sort of a DBA style task where you need to iterate over an object multiple times, so say that you want to load up, just like Ola Hallengren does in his awesome scripts, where you want to load up a list of objects that you need to perform some action on, a table variable is totally cool. When performance matters, table variables are less useful.
Oh, okay, cool. And next question is there any performance impact? Is there any performance impact if indexes are added on temp table?
Performance impact, and I mean, there can be some overhead to adding it. I tend to stay away from non-clustered indexes on temp tables and just add a clustered index if I need to. Generally, though, no, they can, but they can certainly be helpful with queries. There can be some overhead when you load up data, though.
Okay, and there are more questions, a few more questions, but I don't think we have time for that. So
we'll top of the hour or bottom.
Wrap up. So
believe it or not, I actually have to go to work. work. I actually have a job. It's hard to imagine, but
And thank you guys. Thank you, Eric and Brent, for today's great session. And next is let's go to the next slide. The next session is create and load a staging environment from scratch in an hour with BIML with Scott Curry. So please stay tuned and attend the session and follow us at SQL Pass on Twitter, and also share your thoughts on hashtag Pass24HOP and hashtag SQL Pass. And thank you very much for attending this session.
Thanks for having us.
Thank you guys.
Bye.
adios, folks.
Great. Thank you.